Okay, we're going to solve this one by factoring. This is going to be one more strategy to solve your equations. You're going to factor it just like you were factoring the equation. 2x squared minus x minus 1 equals 0. So we set up our parentheses. This has got to be a 2x and an x. This one's got to be a negative 1. So that'll make negative 2 and a positive 1 here. When we set it equal to 0, we set our factors equal to 0. So this would be 2x equals negative 1 and x equals 1. So x equals negative 1/2. Okay, but we know we're not dealing with x. We're dealing with sine x. So we've got two to solve. We've got sine x equals negative 1/2 and sine x equals 1. So we find answers for both of these on the unit circle. Okay, where does sine x equal negative 1/2? Well, first of all, sine is negative in quadrants 3 and 4. Negative 1/2 is going to happen right here at 7 pi over 6 and right here at 11 pi over 6. So far we've got x equals 7 pi over 6. Still got to tack on that plus 2 pi k. X equals, that was supposed to be an 11. Pi over 6 plus 2 pi k. And where does sine equal 1? Where does the y-coordinate 1? Up here, and that's going to be the only place. So we add one more solution of x equals pi over 2 plus 2 pi k. Try this one. It's exactly the same as the other one except for cosine. Okay, here's your solution after factoring. I want you to realize that this says 0 or 2 pi k. These mean the exact same thing. You could do 0 plus 2 pi k, or you could just put 2 pi k. Before we start this one, you have to realize that there are two trig functions in here, sine and a cosine. We have to convert it to 1 before we can solve. So we're going to take sine squared x and change that to 1 minus cosine squared x. So 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. So this becomes 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Combine your like terms. Negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. And then we factor and solve. I'm going to go ahead and take a negative out of everything to make the front term positive. And then I'm going to factor it like normal, just leaving a negative out front. This has got to be a 2 cosine x, and this one has to be a cosine x. And we're going to have both negatives, so minus 1 and a minus 1. The negative isn't going to matter because a negative 0 is the same as 0. Take the factors, set them equal to 0. Now you're going to have a cosine x equals 1/2 and a cosine x equals 1. So we need to find where cosine equals 1/2. Well, that's my short side, so that's going to be at x equals pi over 3 plus 2 pi k. So that's quadrant 1. It's also going to happen in quadrant 4. So 1, 2, 3, 4, 5. So 5 pi over 3 plus 2 pi k. And where does cosine equal 1? That happens at 0, or you could say 2 pi k. Okay, try this one yourself. It factors very similarly using a different Pythagorean theorem identity, then check. Okay, here's your solution for this one. Factors a little differently. You had to use difference of squares right here. Where does tangent x equal positive negative 1? That's going to happen in all four quadrants. So my first solution is for the first and third quadrant, and my second solution is for the second and fourth quadrant. Another strategy to solving these trig functions is to square both sides. Even if we got cosine and sine to the same side, we can't change one to the other. So what we're going to do is we're going to take both sides and square them. So over here, and you do have to FOIL, so it comes out to cosine x plus 1 times cosine x plus 1, and that's going to become cosine squared x plus 2 cosine x plus 1 equals sine squared x. Now we can convert one to the other. Okay, since cosine squared, I have a cosine squared and a cosine, I'm going to change my sine squared x to a cosine, so 1 minus cosine squared. So now this side's going to stay the same. Sine squared x is going to be changed to 1 minus cosine squared x. Move everything over to the, in this case, left side. So I'm going to have 2 cosine squared x plus 2 cosine x. My 1 is going to fall out because I'm going to subtract 1, it's going to be 0. And this equation equals 0. Factoring, there's a 2 and a cosine x in common. What's left over? We've got cosine x plus 1. Set both of these pieces equal to 0. First, divide 0 by 2, you're going to get 0. And this one, cosine x equals negative 1. So where does cosine x equal 0? Meaning where's the x coordinate 0? Well, that's going to happen in two places, which they're going to be pi apart because it's pi over 2 and 3 pi over 2. So x equals pi over 2 plus pi k. Where does cosine x equal negative 1? Where's the x coordinate negative 1? That only happens in one place, at pi plus 2 pi k. Okay, try this one. Similar, slight difference. Watch your conversions and foiling and factoring. Okay, here's your solution. In this case, we had a sine squared x and a sine x, so we converted the cosine squared x to terms of sine. Got everything equal to 0, factored, set our factors equal to 0 and solved, and we come out with these solutions. Okay, this one's a little bit different. It just adds a little bit onto the end. You cannot factor this, so you're going to solve it straight like an equation like we did at the beginning. So we're going to add 1 to cosine 3t equals 1. Then we're going to divide both sides by 2. And then we get cosine 3t equals 1/2. Then we're going to solve where does cosine equal 1/2. And that's what we're going to set 3t equal to. Well, cosine equals 1/2. So when my adjacent side is 1/2, that'd be my short side. So that means I'm at pi over 3 plus 2 pi k. And I'm at, let's see, what other quadrant am I in? Quadrant 4, so that's going to be 5 pi over 3 plus 2 pi k. And the answer is what I divide by 3, which in this case dividing by 3 means multiplying by a third. Okay, we're going to have to think about our solutions when you solve a multiple angle equation. if I'm doing pi over 3 plus 2 pi k, I'm completing pi over 3, and then my next one's going to be 7 pi over 3, and then, let's see, what's 7 plus 6? 13 pi over 3, and so on. For my 5 pi over 3, that's 5 pi over 3, and then we'll have 11 pi over 3, and then we'll have 17 pi over 3. And then if I get rid of my 3t, so I divide all these by 3, which is the same as multiplying by a third. So this is still 3t equals 3t equals. I can go over here and say t equals, that's going to be pi over 9, 7 pi over 9, 13 pi over 9. And then for my other one, this is going to be 5 pi over 9, 11 pi over 9, 17 pi over 9. And what this does to our answer is it changed our rotation. Because now, from term to term, I'm adding on 6 pi over 9, which is what? 2 pi over 3? I'm adding to get from angle to angle to angle. Adding on 6 pi over 9, that'd be 2 pi over 3. So now my answers are, or I guess we were using t, we can stick to t's. So t equals pi over 9 plus 2 pi over 3k, and 5 pi over 9 plus 2 pi over 3k. Okay, try one that's similar. Instead, when you get to the end, x over 2 equals, you're going to multiply your answers by 2. And let's see how it works out. Alright, here's your solution. Where does tangent equal 1? That's going to happen at pi over 4 in quadrants 1 and 3, so we can combine that into one statement. Multiply or spell it out. That's going to happen at pi over 4, 5 pi over 4, 9 pi over 4. And then multiply by 2. Then you get 2 pi, or you'll get 2 pi over 4, which is pi over 2, 10 pi over 4, 18 pi over 4. Reduce those, you get pi over 2, 5 pi over 2, 9 pi over 2. And these are all 4 pi over 2 apart, adding 4 to each numerator, which is 2 pi. So we start with the first one, plus 2 pi k. One more strategy, and the directions will actually say use inverse functions. First, we're going to change it all to one trig function. So I'm going to change my secant squared to 1 plus tangent squared x minus 2 tangent x equals 4. Rearrange and get equal to 0. Tangent squared x minus 2 tangent x equals, that would be a 1, minus 4 would be a negative, oops, not equals, would be a minus 3 equals 0. And then if I factor, it's going to be a tangent x and a tangent x, negative 3, positive 1 equals 0. So tangent x equals 3, and tangent x equals negative 1. That didn't say tangent, that said tax. Okay, we can find tangent x equal to negative 1 by hand. Where does tangent x equal negative 1? That's going to happen in quadrants 2 and 4, catty corner from each other, so that's one statement. And that's going to happen at 3 pi over 4 plus pi k. Tangent x equals 3 is going to be not a normal angle. So we're going to have to solve that by doing x equals tangent inverse of 3. And tangent is going to be positive in quadrants 1 and 3. So it's going to be a plus pi k answer. So I would put this into my calculator, inverse tangent of 3, and then I would put that answer here, plus pi k. And I don't have a calculator with me right now, or I would work that out. Hey, one more time, but this one is already in tangents, so let's just get it equal to 0, try to factor and solve. Okay, here's our solution. First we get it equal to 0, then we factor, set our factors equal to 0 and solve. Tangent x equals 3/4, tangent x equals -2. Again, not good numbers, so we're going to have to use a calculator to get the answers, which is fine. Then we're going to have to add pi k, and the reason you add pi k is because tangent is positive in quadrants 1 and 3, so that's going to be adding pi k. Tangent is negative in quadrants 2 and 4, and so that's also why we add pi k. The calculator is usually going to give you the first positive answer or the first negative answer, so either one you land on, if you landed in quadrant 4 or quadrant 2, you would still add pi k to get there.